Okay, in this tutorial, I'm talking to you about trigonometry, specifically 2022 paper 2 question 9. In the first part of this question, you're given two triangles and you're asked to get the area of this field 1, which is the triangle on the left, and then field 2, which is the triangle on the right. So what I've done here is I've worked out the area of field 1, the triangle on the left. First of all, you go to your maths tables, and the formula for the area of a triangle is a half AB sine C, where A and B represents two sides in the triangle and C represents the angle in between those two sides. Since I have 30 and 35, they're the two sides, and I have the angle in between it, you just sub straight in. And when you sub in, you get a half times 35 times 30 times sine 50. If you plug it into your calculator, to the nearest meter squared, your answer is 402 meters squared. To get the area of field 2, you should focus on the word hence. We're going to follow almost exactly the same method as to get the area of field 1. Except this time, we're going to get the area of the total triangle, the big triangle ADC. Then we're going to subtract the area of field 1. That will leave me with the area of field 2. So the sides of the big triangle are 30 plus 10, which is 40, and 35. So if you plug into a half AB sine C, you get a half times 35 times 40 times the sine of 60. You plug that into your calculator and the total area of the larger triangle is 536 meters squared. Then to get the area of field 2, it's the total area minus the area of field 1. 536 minus 402 leaves me with 134 meters squared. In part B, we're asked to get the perimeter of field 1. Obviously, to get the perimeter, you need the three lengths of the three sides. We know that AB is 30 and that AC is 35, so we need to find the distance BC. We have a non-right angle triangle and we have two sides and the angle in between it, which tells us we need to use the cosine rule. The cosine rule, you take it down from your maths tables, where in this case, that would be the side A, 50 degrees will be the angle A, and then B and C are interchangeable. It doesn't matter which one is B and which one is C, it's 30 and 35. So I'm using, for B I'm subbing in 30, for C I'm subbing in 35, and for capital A I'm subbing in 50. When you plug all of that into your calculator, A squared, or in other words this distance squared, is 775.146. Get the square root of both sides and you work out that the distance BC is 27.84. The question is asking me to leave it to the nearest meter, so I round it off to 28 meters. To get the perimeter then, it's just 30 plus 28 plus 35, and you get your final answer. The perimeter of the field is 93 meters. Okay, in part C, we're told that Oscar is standing here at the point O. 10 meters above Oscar is the flight path of a plane, but the plane P1 is over here. And obviously it's making noise. The speed of sound is 343 meters per second. So the time it takes for sound from this point, or the speed that sound travels from P1 to 0, is 343 meters per second. We're asked to find the time it takes for the sound to travel from the plane to Oscar. Now you should remember, even think of your distance, speed, time triangle. If you're looking for one of them, you cover it and that allows you to find it. So if I'm looking for time, I would cover time, and that tells me that to calculate time, it's distance divided by speed. I know the speed of the plane, or I know the speed of sound, so I just need to find the distance. What is the distance that it must travel to go from P1 to 0? Now, you should recognize this is a 90-degree angle, and they've labeled this as 45 degrees. So obviously the other angle in the triangle is also 45 degrees. It must be an isosceles triangle. If that distance is 10, then that distance is 10 as well. To be honest, you don't even need to use that for this part of the question, but it's useful to just know that heading in straight away. The one thing I need to find is the distance. In other words, I need to find the hypotenuse of this right angle triangle. You could use Pythagoras' theorem here to work it out, but I'm going to use cos. I know the cos of an angle is adjacent over hypotenuse. And in this case, I could say the cos of 45 degrees, if I was taking this as my 45, well, adjacent to that is 10, and the hypotenuse is the thing that I'm looking for. So the cos of 45 is adjacent over hypotenuse. Then what I could do is multiply both sides by h, and also divide both sides by cos 45. Essentially swapping the h and the cos 45. And I end up with h is equal to 10 over cos 45. And if you plug that into your calculator, h works out as 14.142 kilometers. Now you have to be careful here because the speed is given in meters per second. So obviously that means the distance needs to be in meters. I can't be using kilometers for my distance and meters for my speed. So there's 1,000 meters in a kilometer. So you multiply this by 1,000. The distance from P1 to Oscar is 14,142 meters. So the sound travels at this speed, and it has to travel this distance. So time is simply distance divided by speed. And if you plug that into your calculator, 14,142 divided by 343 to the nearest second, your answer works out as 41 seconds. In C part 2, we have this diagram. Remember, we know that when the airplane is at P1, it takes 41 seconds for the sound the airplane makes to get to Oscar. Now obviously the airplane is moving along, so after 41 seconds, the airplane is no longer at P1, it's now at what's referred to as P2. We're asked to work out what is the angle labelled here. So it's passed directly over Oscar's head, and what is the angle it's making with a vertical line directly above Oscar. So let's just fill in what we already know. We know that that angle there is 45 degrees. We know this angle here is 45 degrees. We know the vertical distance from Oscar to this flight path is 10. And we know the distance from P1 to here is also 10. Now obviously the first thing we need to find is the distance from P1 to P2. How far has the plane travelled in 41 seconds? To get distance, it's speed multiplied by time. We're told that the speed of the plane is 255 meters per second. And obviously the time to go from P1 to P2 is 41 seconds. If you multiply 255 by 41, that tells me the distance from P1 to P2 is 10,455 meters. Or in other words, it's 10.455 kilometers. Since I know the distance from P1 to here is 10 kilometers, then obviously I subtract 10 from this value, and the distance there, that distance from vertically above Oscar to P2 is 0.455 kilometers. I'm writing it in kilometers since all the rest of that diagram is in kilometers. We need to be consistent. So the plane travels 10 kilometers and then a further 0.455 kilometers. But now if you look at this triangle, we now have enough information to get theta, because I know two sides in the triangle. Look at your angle theta. I know that the adjacent is 10 and that the opposite is 0.455. If you're dealing with the adjacent and the opposite, you're dealing with tan. The tan of an angle is opposite over adjacent. So I can say that tan theta is 0.455 divided by the adjacent, which is 10. And obviously now to get theta on its own, you get tan inverse of that fraction. And if I simply plug that into my calculator, I'll get the answer for C part 2. So when you plug this into your calculator, your answer for theta is 2.6 degrees. Okay, in D part I, we've got the same plane, we've got the same flight path, except this time, P3, the time it takes for the sound of the plane to go from P3 to Oscar is the same as the time it takes from P3 to P4, but it's symmetrical this time. The distance from P3 to being directly above Oscar's head is D, as is the distance directly above Oscar's head to P4. So it's a symmetrical graph here. The things that are equal here are the time it takes for sound to travel from P3 to Oscar is the same as the time it takes for the plane to travel from P3 to P4. So that's what we can equate, and that's where the equation is going to come from. Let's try and work out the time it takes the plane to travel from P3 to P4. Remember that time is equal to distance divided by speed. The time it would take to get from P3 to P4, well, the distance the plane travels is d plus d, or in other words, it's 2d. And the speed of the plane is 255 meters per second. But remember that this diagram is in kilometers, so 255 divided by 1,000 is 0.255 kilometers per second. That's the speed of the plane. And as you can see, we already have one of the fractions we're looking for. The other thing, the thing that's equal to is the time it takes the sound to travel from P3 to O. Now there might be a little bit more work involved here. Obviously that means I need the distance from P3 to O. You should recognize that we have a right-angled triangle here. And I want to work out what is the hypotenuse of the triangle, the distance from P3 to O. And I want the hypotenuse in terms of D. So if I was using Pythagoras here, I would say that 10 squared plus D squared, and I'm calling this x, so 10 squared plus D squared is equal to the x squared, which is my hypotenuse. 10 squared is 100, so I get 100 plus D squared is equal to x squared. Obviously I'm not concerned with x squared, I'm concerned with x, so I get the square root of both sides. X, this distance from P3 to Oscar, is the square root of 100 plus D squared. As we said a moment ago, the time from P3 to O is distance divided by speed. So the distance in this case is simply x, or in other words, it's the square root of 100 plus D squared divided by the speed of sound, and the speed of sound is 343 meters per second. We divide that by 1,000 and we get 0.343. And that's where it comes from. You can mathematically show your work there, and if you displayed like the time is distance over speed, you can show where that's coming from. So in D part 2, we simply have to solve that equation. There's nothing particularly complicated about it, we just have to work through it. The first thing I decided to do was get rid of my fractions. I multiply both sides by 0.255, so I get it up on the top on the left. I also multiply both sides by 0.343, so it's on the top on the right. All I did on the next line was 2 by 0.343 is 0.686d. On this line, I decided to square both sides. If you square the left-hand side, it gets rid of the surd. 0.255 squared is 0.065025. And if you square the surd, you're left with 100 plus d squared. On the right-hand side, 0.686 squared is 0.470596, and d becomes d squared. Then I just decided to multiply out my bracket, the coefficient by 100, then the coefficient by d squared. At this stage I noticed I had a term with a d squared on the left and a term with a d squared on the right, so I decided to move them all to the right hand side. In other words, I took this term and I subtracted it from both sides. 0.470596 minus this value is 0.405571 d squared. Finally, to get d squared on its own, I divided both sides by the coefficient of d squared. And when you plug that into your calculator, d squared is 16.03. Then obviously to get your final answer, you get the square root of both sides, and to one decimal place, your answer is 4 kilometers or 4.0 kilometers.